Now, this substitution will cover a lot of cases, right? So what is the case that is not covered? When both powers are even. Right? So let's look at that case. And well, what would be? Let's do the simplest case. Integral of sine squared of x dx. And at this time, instead of doing substitution, I will try integration by parts. Now, if you want to do integration by parts, you would like to see two parts, and one of them better be already a derivative of something, right? Because you will have to integrate it, and the other part will be differentiated. So it's easy to differentiate any trigonometric function. It's not easy to integrate any trigonometric function. So can you integrate sine squared? Well, obviously not, so let's separate it into sine times sine. And then say we are going to use one of them for differentiation and the other one for integration. So v prime is going to be the other sine of x, and then u prime is cosine, and v is the integral of sine, which is negative cosine. And then I proceed with integration by parts. That integral is u times v minus the integral of that product of cosine x times negative cosine x. And of course that negative sign factors, and they end up with sine x times cosine x plus an integral of cosine squared. Am I making my integral easier? I'm making it different, right? Now, what happens here is that this integration by parts will not simplify the integrand. But then you have to use exactly that identity again. So let me apply that identity. And I will have integral of 1, so cosine squared is 1 minus sine squared. I have integral of 1 minus an integral of sine squared. And now what happens is that I'm back to exactly the same thing, right? Which makes me not happy. But if you look at this equality, the integral I don't know is equal to something plus the integral I don't know, and it's the same integral. I can use this equality and bring the integral to one side and solve for it. Now I can use this equality as equation for my integral. And my integral doesn't cancel. That's the important part. If I had plus here, it would cancel and I would get no information about my integral. But I have minus, and that's exactly what will make this integration by part works all the time. When you proceed with integration by parts, you will have the same integral showing up, but it will be with some coefficient other than 1. So you use this equality as an equation. So if I take this integral to the left, I will have twice the integral of sine squared equals negative sine x times cosine x plus integral of 1 is x plus a constant, of course, and then you divide by 2 and we are done. So the curious thing to notice here is that you started with a completely trigonometric function for integration. And who would normally guess that an integral of trigonometric function would involve a polynomial function, like x over 2? So that was something curious I noticed while taking the integral. But I would normally expect trigonometric function, right? And then you differentiate it to get trigonometric function, but not. Well, what you actually get is a linear function, and derivative of that is a constant. And the constant contributes using that identity, right? You can always write a constant as a sum of trigonometric functions. All right, so what I'm suggesting here is whenever you see product of even powers, you proceed exactly this way. You do integration by parts.